Okay, today we're going to look at section 1.6, talking about other types of equations and applications. We'll start with rational equations. Rational equations being fractions. So we determine any restrictions based on the domain, and we solve by multiplying by the least common denominator. So, looking at this first problem here, I see that x cannot equal -1 because I will be dividing by 0 and cannot have that. Now we need to find a common denominator. The least common denominator. So the least common denominator on the right side is just 1. So my overall least common denominator, my LCD, is 2 times x plus 1. So what's that give us? What we do is we take 2 times x plus 1 and multiply it by both sides. Oops. Plus 5x over x plus 1 equals x times 2 times x plus 1. So when we do this, what happens here? This 2 here cancels out this 2. So I have 2x minus 3 times x plus 1. Here the x plus 5's cancel out. So I have plus 2 times 5x. And here I have 2 times x plus 1. So this gives me 2x squared plus 2x minus 3x minus 3 plus 10x equals 2x squared plus 2x. So let's put together all our common terms. I have a 2x squared here. I'm going to subtract it, so this will go away. Here I have 2x minus 3x, which is negative x. I'm going to subtract this 2x. I have negative 3x, and oops, forgot about this 10. So that gives us 7x total. Then I have minus 3 equals 0. So I have 7x equals 3. So x equals 3 over 7. So let's look at this next one here. What do I know? Again, x cannot equal -1. X cannot equal 0 either. And if we factor this, we get x times x plus 1. So we're okay. We have a least common denominator of x times x plus 1. So we multiply both sides by that, we get x times 4x plus 3 plus 2 times x plus 1 simply equals 1. So this is 4x squared plus 3x plus 2x plus 2 equals 1. Now I have 4x squared plus 5x plus 1 equals 0. This factors the 4x plus 1 times x plus 1 equals 0. The 4x plus 1 equals 0. X equals -1/4. That's not one of my missing answers. Here we have x plus 1 equals 0. X equals -1. Can't have that. So this is my answer. Okay, this will factor into x minus 6 times x minus 2. So x cannot equal 6 and x cannot equal 2. Have my LCD, which is x minus 6, x minus 2. I multiply through, so I get 1 times x minus 6 plus x, or 1 times x minus 2 plus x times x minus 6, and here I simply have 4. So this is x minus 2 plus x squared minus 6x equals 4. I got my x squared. I got 1x minus 6x minus 5x. I have negative 2. Subtract 4. I get minus 6 equals 0. And this will factor to x minus 6 times x plus 1 equals 0. So x equals 6, or x equals negative 1. X cannot be equal to 6, so x is negative 1. Again, take your time, go through. You are able to check your answers as well in these. If you have time, I highly recommend doing so. Okay, so now we're looking at rational expressions or rational equations. First step is to isolate the radical. Raise each side to the appropriate power to undo the radical. Solve the equation, and you must check your solution. So we need to isolate this. So add 8 to both sides. I get the cube root of 4 minus x equals 3. Now I cube both sides. This gives me 4 minus x equals 27. Bring my x over here. X equals negative 23. Now test it. The cube root of 4 minus negative 23 minus 8 equals negative 5. So this is the cube root of 27 minus 8 equals negative 5. Cube root of 27 is 3 minus 8 equals negative 5, and that is accurate, so this is the correct answer. Let's look at another one. Okay, square root. So my radical is already isolated. Square both sides. I have 12 minus x equals x squared. Go ahead, add x over here, add 12 over here, and what do I get? That is not factorable. That's because I'm not adding 12. I am subtracting 12. So this will factor into x plus 4, x minus 3 equals 0. So x equals negative 4, or x equals 3. So 12 minus negative 4, does that equal negative 4? Well, this becomes the square root of 16. This is plus or minus 4. So I would say yes. Some places may say no, but I would say yes. So let's look at the square root of 12 minus 3. Does that equal 3? Yeah, we get the square root of 9 equals 3, and that is, well, square root of 9 is plus or minus 3. So I would say yes again. Okay. This one's going to get a little messier. So we need to add 17 to both sides. So I have the square root of 9x plus 117 equals 2x plus 17. Square both sides. I have 9x plus 117 equals 4x squared plus 68x plus 189. 289. 289. Okay, so we're going to subtract 9x from both sides. We get 4x squared plus 57x. Subtract 117 and we get plus 176. And that equals 0. Now that may factor, I'm not sure. But we'll go with good old x equals negative b 57 plus or minus the square root of 57 squared minus 4 times 4 times 176 over 2 times 4. So we have negative 57 plus or minus the square root. 57 squared, 3249 minus 4 times 4 times 176. 2816 all over 8. So we have negative 57 plus or minus square root of 433, which does not look good, 8. And it does not work out nice and even. So checking it would be kind of difficult as well. Okay, so we have equations that are quadratic in form. Use an appropriate substitution to turn the equation into a quadratic expression. So if I let y equal x squared, this becomes 4y squared minus 8y plus 3 equals 0. Okay, so now solving for y, negative b, negative of negative 8, plus or minus the square root of negative 8 squared minus 4 times 4 times 3 all over 2 times 4. So we have 8 plus or minus square root of 64 minus 48 all over 8. I have 8 plus or minus the square root of 16 over 8, which is 8 plus or minus 4 over 8. So 8 plus 4 equals 12 over 8, which is 3/2. 8 minus 4 over 8 equals 1/2. So that's y. So x squared equals 3/2, or x squared equals 1/2. So x is equal to plus or minus the square root of 3/2, which is plus or minus. Now what we want to do is multiply this by the square root of 2 over 2, which is 1. What that does is that gives me in the numerator a 6 and the denominator a 4. So I can change this to the square root of 6 over 2. We don't want radicals in the denominator of a fraction. Same thing here. So x equals the square root of 1/2. Multiply this by the square root of 2 over 2. And get the square root of 2 over 2. Plus or minus, don't forget that. And again, you can plug these numbers in and see what happens. Okay, we have the same situation here. Again, let y equal x squared. So we simply have y squared plus 5y minus 50 equals 0. Now this one factors nice and easily. Y plus 10 times y minus 5, which means y equals negative 10 or y equals 5. So x squared equals negative 10, which would be plus or minus the square root of 10 times I, or x squared equals 5, x equals plus or minus the square root of 5. Okay, now here we can let y equal x minus 4 squared. So now I have 8 times x squared minus 10 times x, and go ahead and add the 3. So quadratic formula, x, oops, I changed that to y, didn't I? Y squared y. So y equals negative of negative 10 plus or minus square root of negative 10 squared minus 4 times 8 times 3 all over 2 times 8. So we'll get 10 plus or minus the square root of 100 minus 96 all over 16. So 10 plus or minus 2 over 16, which is 8 over 16, or 12 over 16. So now we have x minus 4 squared equals 8 over 16. Equals 4 plus 2 times the square root of 2 over 4. Actually, that should be plus or minus. And if I look at the other answer, x minus 4 squared equals 12 over 16. I get x minus 4 equals plus or minus 2 times the square root of 3 over 4. X equals 4 plus or minus 2 times the square root of 3 over 4. These can get a little complex. Right, so the main trick to this is take your time, be careful, watch for mistakes. Hopefully any tests I give you will have prettier answers, I should say. And you won't come out with these, and you'll be able to check them all. It's very important to check them when you can. Okay, that's all for this one. Have a good day.